I'm going to introduce to you the concept of average atomic mass in this video. Once you've watched this video in class, we will expand on it in some of our group activities for the day. Okay, so this is carried out or examined in section 2.8 in your textbook if you need to read about it as well. So, atomic mass, the average mass of an element. It's coming off our periodic table. Let's define some terms. Atomic mass is the mass of an atom in atomic mass units. Okay, so that is what an atomic mass is. When you look at a periodic table, one of those numbers associated with the elements is its atomic mass. So what is an atomic mass unit? Well, this is a way of defining an amount, okay, and it's got a base scale, and this is how they determined what an AMU was. They took 1/12 of a carbon-12 atom, okay? So let's draw a carbon-12 atom, okay? So we have, and I want to draw it as a flat sphere because, well, just because I can divide that in 12 pieces. Let's say that this equals 1 atom, okay? Now I want to divide this little atom into 12 equal parts, okay? So you're going to imagine these are equal parts, because I am certain they're not really equal, as you can say, but there's 12 pieces, okay? So 12 parts, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I took this atom and I divided it into 12 equal parts, okay? And I took one of these little parts and I said that that little part would then weigh 1 AMU. That is how they define the atomic mass unit, by taking 1/12 of a very specific atom. It's not just any atom, it is a carbon-12 atom. Now, we did some work, we learned about carbon-12, and we know about that a little bit from previous activities. So let's answer some questions about carbon-12. Okay, first question. What makes up a carbon-12 atom? You might need to stop and look at a periodic table in order to come up with the right answer. Once you've selected the answer, then continue. Well, hopefully you said A. There are 6 protons, 6 neutrons, and 6 electrons. How do we know that? Well, when we look at the periodic table, we see that carbon is the atomic number of 6. This is the number of protons. And then we know that the 12 is the number of protons plus the number of neutrons. Since there's 6 protons, there has to be 6 neutrons to come up with that. And then the electrons have to match the number of protons. Okay, so this is going to be the equivalent to 6 electrons because it's a neutral atom. So that's why A is the right answer. Okay, now I want you to look back at the definition. So you need to flip back in your notes. What's the definition? Okay, now I want to tell you, I'm not talking about 1/12 of this thing. I'm going to hand you a whole carbon atom. So I'm giving you the whole atom. Which one of those would be the mass of one atom of carbon-12? This is not supposed to be complicated, all right? Just logically work your way through and come up with how much the whole atom would have to weigh. Okay, hopefully you came up with the answer C, that it would have 12 AMUs. If the definition of 1 AMU is just this one little piece here, that's 1 AMU, and the whole atom has 12 of those, then the atom would have to weigh 12 AMUs. All right, now when we go to the periodic table and we look at the value given to us on the periodic table, it doesn't say 12, it says 12.01. The question is, why doesn't it say 12? Well, carbon is not just carbon-12. Carbon is made up of a lot of different isotopes of carbon. There's carbon-12 and carbon-13 as the most common. That makes up the vast majority of it. There's other little pieces of, some of it might be carbon-14 and so forth. But that's the lion's share of carbon. And when I go to the periodic table and I see that they have given me a value of 12.01 for the atomic mass or the atomic weight of carbon, it is a weighted average of these. Now, what do we mean by weighted average? What is a real average to you in your mind? You add up how many you have and you divide by 2. So you take the mass of this, divide by 2, and that would be the average mass. but that's not a weighted average. A weighted average takes into account the relative abundance of these isotopes. Way, way, way more of a natural sample of carbon is going to be made up of carbon-12. A small portion of it is going to be carbon-13. So if I want to do a weighted average, it's going to be much more contributed by the carbon-12 than it would be the carbon-13. Now, your grade in this class is an example of a weighted average. Your exams that you take are much more heavily weighted towards your final exam grade, your final grade for the class, than your homework average, okay, or your class participation average, or your recitation average. So a student who gets F's on all their tests but aces everything else might still get an F because the exams are weighted so much more heavily towards your final grade. That is the way this works. Okay, now let's do it more optimistically. Let's say you get an A on every test and you just blow off your homework. Okay? Blowing off your homework and you never attend class. You might not get an A in the class, but you're still going to get a decent grade because the exams are so much more heavily weighted for your overall grade. And the other things are pulling you down a little bit. So that is what a weighted average is in our world of chemistry. And if you want to know what those real weights are, you can look at your syllabus and we tell you this percentage of it is due to this test, this percentage is from your recitation, class participation, here's your in-class participation and your homework. There's all kinds of this breakdown for the weighted average. So we're going to practice doing a weighted average and see how it works. Okay? So I told you information that this was way more carbon-12 than there is carbon-13. Now they're telling me numbers. It's 98.9%, okay, carbon-12 and 1.10% carbon-13. Now we took it out to more than 2 decimal places in the percent world. We might be able to find a little carbon-14 or some other things in there. I'm also telling you 2 other things. Carbon-12, we know by definition of an AMU, weighs exactly, I could put as many zeros on there as I wanted to, AMUs. The carbon-13, on the other hand, is 13.00335 AMUs. There is no other isotope mass that you ought to know. This is the only one, by definition, has to weigh exactly 12. If it's carbon-13, it doesn't weigh exactly 13 because the protons and the neutrons don't weigh exactly the same as each other and there's electrons in there. But this is the mass of one single atom of carbon-13. So to do a weighted average, what you're going to want to do is take this percent and get the fraction out of it. So was 98.90 is the fraction is 0.9890. Notice I've just moved the decimal place over. This is how much of it out of 1 you have. So you take that fraction times the mass of this isotope. Okay? And then you go to the next one. You add to it, okay, turn this into a fraction. So that 0.0110, there is the fraction of it times its mass, 13.00335 AMU. So this is a weighted average. We're taking the fraction of this isotope plus the fraction of this isotope. If this were a regular average that you're kind of used to, it'd be 0.5 times this plus 0.5 times this. That would be the same as saying this plus this divided by 2. But it's a weighted average. So now when we do the mathematics of this process, what we end up to 4 significant figures is 12.01 AMU. So that is the weighted average. When we go to the periodic table and we look at the atomic mass of carbon, it is the average based upon the relative abundance of those isotopes. So when I see a 12.01 AMU, I know that it is mostly carbon-12 because it's weighted much more heavily to carbon-12 and just a little bit of carbon-13. Now, before we leave this topic, let us look at your periodic table and look at boron. If you were to look at boron and look at boron's atomic mass, okay, 10.81. Now, if I told you I've got boron, and you can't know this by looking at the periodic table, but if I told you that boron has 2 major isotopes, boron 10 and boron 11, Could you tell me which you had more of in nature? Remember that the average here is a weighted average of the relative abundance of those two isotopes. So which one is it closer to? Is it closer to boron 10 or is it closer to boron 11? Well, 10.81 is closer to boron 11. So I can look at a mass off the periodic table, and if I knew the isotopes that existed, which again, you cannot get off the periodic table, but if I told you, hey guys, boron consists of these two isotopes, here is the average, which one do you have more of? Because this average is closer to boron 11, I know there is way more boron 11 than there is boron 10. So the weighted average has given us that information about our elements. Let me see if there's anything else I want to discuss before our next class. Nope. In class we're going to just be working with this concept more and maybe do it in reverse. If we knew this, could we figure out what percentage of it is boron 10, what percentage of it is boron 11, and those are the kinds of problems we should be able to do with a weighted average.